Hi everyone. Today we are going to review the RCM Reliability Center maintenance of the gas turbine based on FMEA failure mode effect analysis of the gas turbine. As you can see, this is a picture of the gas turbine, and this is the typical gas turbine package. And we have an exhaust system, air intake system to gas turbine, control panel, fuel system, power of turbine, lube oil system and console, gearbox, and compressor. We are going to review the FMEA failure mode effect analysis component by component for major component of the gas turbine. This is the gas turbine component failure mechanisms, and I have a picture of the cutaway view of the gas turbine, and this is the view of all the main components. This is the component of the failure mechanism and probability of failure for each component based on the failure mode and failure analysis. Okay, and it's going to be the review the probability for mitigated probability or unmitigated probability. And the highest level of the probability is 4, and lowest level of the probability level 1. So this is the main component is compressor, IGV system. As you see, our IGV system, this is a very critical component in gas turbine to analyze and measure and control the fuel and air ratio to make sure fuel and air ratio. This is in the design and the functioning range and threshold. Any change of the out of these thresholds is going to be directly impact of the functionality of the gas turbine. The failure mechanism is the IGV bushing, erosion, and failure mode is gas turbine damage due to ingestion of the warm bushing. Mitigated probability very low, and unmitigated probability level 2. Again, same component, compressor, incorrect IGV angle. This is back to installation of the IGV, and failure mode is shut down due to surge of the high vibration. We're going to face this vibration. Vibration could be inspected and detected by vibration devices, and this could be caused the blade fracture due to aerodynamic induced cycle stress. Mitigated probability very low, and blade fracture is unmitigated, ultimately going to be result to fracture of the blade. Another failure mechanism for compressor and blade component, subcomponent of the blade and rain is falling. By the time we're going to face and encounter with falling and build up the scales on the blade and cause of the falling. Unrecoverable performance and efficiency losses, high vibration and shutdown of the compressor. Unmitigated is high probability. If we don't mitigate this issue, then it becomes to high probability of the shutdown compressor. Again, compressor component, we have erosion, Exactly same thing. The blade fracture, we have a damage on the erosion, and unmitigated is high probability. Foreign object damage. This foreign object damage could become founded during the disassembly of the during the maintenance, and some foreign object may be interred by not using the clean fuel and causes catastrophic gas turbine failure and with high probability and high vibration shutdown could be happened. High cycle fatigue cracking and cracking the compressor blades. Secondary damage due to release of the failed component. Again, is high probability and could cause the unmitigated, could cause the compressor shutdown. High cycle fatigue is based on the hours of the operation for how long compressor running without shutdown and overhaul and turnaround. Compressor subcomponent is a blade valve. Incorrect opening and closing of the blade valve. Dysfunctional problem on the blade valve. Surge shutdown during the startup. High exhaust temperature and could cause the shutdown. Second damage due to change of the airflow pattern, which all of this failure effect is could cause the high probability, as you can see 3 and 4, if not mitigated, and no PM preventive maintenance happened on this blade valve. So another main component is air intake system. Subcomponents air intake filter and failure mode high pressure drop across the intake filter, and failure of analysis is opening of the bypass door, engine shutdown due to surge of the high vibration, and the probability is not that high. That's again component air intake system, component air intake housing, and failure mode corrosion in air intake housing and ducting. Failure effect is a fouling erosion in gas turbine blades. Foreign object damaged. Foreign object damage is a high probability because if something objectives, foreign object is entered by air intake housing to the system, and could unmitigated could result of the gas turbine is shut down. Another main component is combustor, subcomponent liner, failure mode crack due to internal fatigue. This is very credible and applicable for crack on the liner. Failure effective crack combustion liner, secondary damage due to excessive combustion vibration and potential of the, this is going to a combination of the thermal fatigue and mechanical fatigue together on the liner, and potential release of the combustion liner material. As you can see, this is unmitigated with a high probability to shut down the compressor. And by mitigation and PM, one level probably could be dropped. Combustor and subcomponent of the liner, localized hotspots. Localized hotspot is a failure effect is the metal loose and burned through the combustion because high temperature, and unmitigated probability is high. And another failure mode, high temperature oxidation of the liner. Failure effect is surface degradation and cracking. during the high temperature oxidation, and unmitigated is high probability level 3, and if during the PM we can drop the probability to very low probability level 1. Another failure mode for liner is hot corrosion, surface degradation and cracking, and again high probability of unmitigated. Fretting damage, excessive wear on the matting surface, cracking the joint area. This is normally back to initial or overhaul maintenance, wrong installation, and wrong joint mistake, human mistake during the installation happen. And this is not very high probability on unmitigated, but for PM and correct maintenance probability could be dropped. For combustor component and sub-component fuel nozzle, we have a crack due to thermal fatigue on the fuel nozzle. Failure if effect is crack in the fuel nozzle, change in the flame pattern resulting in the uneven temperature on combustion and turbine section of the localized hotspot. Again, this damage is high probability if there is no preventive maintenance and predictive maintenance is in place, but could be dropped to lower probability after correct preventive maintenance. Fuel nozzle could be clogged nozzle, changing the flame pattern resulting in the excessive temperature spread on the combustion and turbine section. Some of the regular damage could be, you can see the combustion and ununiform distribution of the flame, and could be, we can face and encounter with flame impingement damage as a result of this failure mode. And again, probability level is high, but could be aligned there and clean the nozzle during the maintenance and drop the probability to lower probability. Fuel nozzle fretting, excessive wear on the matting surface of the fuel nozzle and injection. This is back to the installation during the maintenance. Maybe we have no proper and adequate matting surface, and with correct roughness on the surface could cause this damage of the fretting. So again, we are on the combustor component and the subcomponent cooling holes. Again, we have a failure mode, clog of the cooling holes, and which cause the thermal erosion in the nozzle, burn through the combustion chamber, flank of the thermal barrier coating, and we can face with localized hotspot. This localized hotspot could be detected by infrared camera and thermography inspection. Again, all those is a high probability if it's not maintained and if it's not overhauled and proper preventive maintenance in place. But after maintenance, we can drop the dose probability of the damage and failure to 2 levels lower. Another main component can produce a turbine. Subcomponent nozzle, again, failure mode crack due to thermal fatigue. We have creep damage because of high temperature, rubbing and seizure of the rotating component because high temperature surface and the contact surface is going to be seized. And but this is not a high probability of the damage. Another failure mode, high temperature oxidation we have because of the because of the very high temperature, surface degradation, and crack as a failure if effect. And again, this is unmitigated high probability. We are in the component of the gas producer's turbine, subcomponent bucket, failure mode crack during thermal cycle, crack due to high cycle fatigues, creep damage, and high temperature oxidation and hot corrosion. This is all related to high temperature damage, okay? Creep, high temperature oxidation, hot corrosion, and could be, and failure effect is a crack of the turbine bucket, cracking turbine bucket, secondary damage due to release of the turbine bucket, robbing and seizure of the rotating component because of the failure mode creep. And as you can see, all of them is a high probability to damage, to failure, if we are not mitigated this failure. But failure modes could be dropped with lower level if you have a preventive maintenance. Again, we are on the component of the gas producer turbine, subcomponent disk, and in this component we are faced of the high temperature. Again, we have creep damage, robbing, seizure of the rotating component, crack due to thermal fatigue, and with combination with stress, very high of the cycle of the fatigue, combination with thermal. Cracking a turbine disk could be happen as a failure effect. Secondary damage due to release of the turbine bucket. Turbine bucket ejected at a high velocity, and the failure could be that turbine bucket could be ejected during the operation and running. As you can see, we have unmitigated probability very high, and we can drop the one level probability by overhaul and maintenance during the turnaround. Another main component is power turbine. Subcomponent is nozzle. Failure mode is crack by thermal fatigue, creep, high temperature oxidation, and again we are facing the encounter with high temperature operation in this system. And failure effect is a crack in power turbine nozzle, secondary damage due to release of the nozzle metals, robbing and seizure of the rotating component, surface degradation and crack, and some of the items failure affects high probability but could be dropped properly by mitigation. And we still on the power turbine component, bucket, subcomponent, and we have a failure mode crack during thermal fatigue, crack due to high cycle fatigue, creep, high temperature oxidation. All this component, main component is facing with high temperature, and failure effect is the robbing and seizure rotating component on the creep damage, surface degradation, cracking, and this is the high probability of failure if not mitigated. We are still on the component power turbine, disk, subcomponent. Failure mode is crack due to thermal fatigue and creep. Failure effect is again secondary damage due to release of the turbine bucket. Turbine bucket ejected, exactly same as some other damage. And creep, we still have a creep damage, robbing and seizure of the rotating component. Unmitigated probability high, but could be dropped one level by mitigation. Another main component, exhaust system. subcontinent exhaust collector, failure mode crack in exhaust diffuser and heat shield fatigue, failure effect crack in the exhaust diffuser and heat shield, collapsed exhaust diffuser and heat shield causes the secondary damage. And as you can see, we have a high probability for unmitigated and without maintenance in place. And next component interface with driven equipment, gas turbine driven equipment, and failure mode misalignment. This has happened during the mistake during the maintenance, wrong maintenance, error in the human error during the preventive maintenance, and the failure effect is excessive vibration, heat, and noise equipment. Because all of them could be detected by infrared camera, noise detector, and level of the decibel noise. And this damage could be detected during the run. Bearing failure by vibration and misalignment, loss of the shaft. Shaft could be crack and wear out. Robbing, seizure of during the misalignment of the shaft, could be temperature could be raised and seized. And finally, possibility of the shaft crack and fracture. We have a high probability unmitigated, and by proper and adequate maintenance, probability level could be dropped significantly. Another main component is bearing, subcomponent radial bearing, truss bearing, and failure mode bearing failure, truss bearing failure, and the failure affect is metal fatigue and pivot fritting, and this fritting is very high probability if it's not overhauled and replaced, but could be dropped significantly. Probability could be dropped significantly if you have a good maintenance in place. Another main component is coupling. Failure mode is coupling failure. Failure affects inability to transmit the required torque. And again, this failure could be happen during the wrong and improper maintenance. Unmitigated is high probability, but could be dropped to very low probability by mitigation. Another main compound, loop oil system. Failure mode is loop oil degradation. Failure affect extensive vibration because of the degradation and of the loop oil, and maybe we face the heat, noise, extra vibration. Bearing failure could be happen. Shaft could be fracture and failure, and rotating components produce the heat and temperature, and this is a unmitigated without replacing the oil, high probability damage and failure, but could be dropped with lower probability with replacing the oil in the schedule and planning. Another main component is fuel system. Failure effect is fuel system contamination. Failure effect is thermal erosion, hot corrosion, high temperature oxidation, and unmitigated probability high, but could be dropped to 2-level probability lower to lower probability by maintenance. Another failure mode, improper fuel supply control during startup or during the operation. and failure affect is high temperature shutdown could be happen, unable to sustain the combustion. We have unstable combustion happening, and the frame out during the startup, which is not very high probability unmitigated, but could be dropped in probability with one level lower. Another main component is control system, and failure mode operation outside of the operating envelope, uh, integrity operating envelope IOW, and failure affected high exhaust temperature shutdown, high vibration shutdown, use of the containment, and as you can see is unmitigated without maintenance probability very high, but could be dropped to two level lower probability by proper maintenance, overhaul, and turnout. Thanks for your attention and have a good day.